Hey guys, hope all are fine. So in this video we will see how to use a potentiometer. Okay, so this is a potentiometer. So actually this is a 5k potentiometer. Okay, the value will be written there itself, and this is a 1k potentiometer. Okay, so you have different potentiometer. Basically a potentiometer is a device which with which we can vary the resistance. Okay, see, you can rotate this knob so that you can vary the value of this resistance. Okay, so here you can use this potentiometer as a single value constant value resistor also. So before checking the resistance value, make sure that in your multimeter your knob is set to your resistance. See, I am setting it to 5k because this is a 5k. I'm setting it to 20k. Okay, because this is a 5k. Because if I set it to 2k, the value will not be shown because the resistance value is greater than this setting value. Okay, so in case if you want to use this as a single value resistor, you can use these extreme points where you can see the value is 5.39, right? Actually it is showing a higher value. This resistor has some higher value. Okay, it is not 5k, it is slightly higher than 5k. Okay, see these extreme points, the end points, can you see this? The point extreme left and extreme right will give you the fixed value irrespective of your knob. Wherever you rotate your knob, see now it is in the minimum. If you makes it to the maximum also, it will show you the same value. See, it is giving the same value. Okay, so irrespective of this knob, if you are using this resistor as a single value resistor, then you can use these extreme 2 points. Okay, so in case, but ultimately what is a potentiometer? You know, it is a variable resistor, right? So we need to set our own value by changing this knob. So for that you have to take the center pin out. Okay, the center pin is the variable resistor output pin. Okay, so in that case you can use either the left and center pin or the right and the center pin. Okay, see now in this you have to understand one more thing. See, now I am rotating this knob to the leftmost corner. See, this knob is in the leftmost corner, that is anti-clockwise. Okay, now if I rotate it to the most anti-clockwise direction and if I measure the resistance, it is showing 0. Okay, so 0 value resistance is these two pin. Now if I slowly increase or gradually increase this, rotate this knob in clockwise direction from 0, slowly your resistance will increase. As you can see, can you see this? So now it is 2k. If you want some more, you can rotate it again. See, now it is 2.9. so like this, if you use this left corner pin and the center pin, your left hand side, your knob position at the leftmost corner will be 0. From there, if you want to increase, slowly you can gradually rotate it clockwise. Similarly, you can use the rightmost pin also. So in this case, see now I have rotated my pin to the rightmost most clockwise direction. Okay, now I am keeping my multimeter pins to the right pin. See, center pin and the rightmost corner pin. So it is showing 0. Okay, now if you want to use these two pin, slowly from 0 you have to rotate it anti-clockwise direction. Now I am rotating it in anti-clockwise direction and I am measuring the resistance value. See, it is increasing. So slowly again we can increase it, and if we measure it, it is increasing. Okay, so if you want to use this leftmost corner pin and center pin, your fully anti-clockwise closed knob will be 0. From there you have to slowly rotate it clockwise for increasing. Similarly, if you want to use this right corner pin and center pin, your 0 will be fully clockwise closed knob. From there, if you want to increase the resistance, slowly you have to rotate it anti-clockwise direction so that the resistance will increase slowly from 0 to 5k. Okay, so that is how you have to use this pin. Actually, using this, you can use all these 3 pin also. Okay, either you can leave one pin alone. Okay, in this case I have given connection for 2 pins, which means I can use only this left corner and center pin. This right pin I can leave it alone, there is nothing wrong in it. But in some circuit you might see they have used third pin. This pin might be connected to the ground. I will tell you what is the purpose, okay? When I later on in this video, when I teach you circuits, I will tell you why we have to connect this pin and why it is not necessary to connect this pin, okay? But this whatever I told you, like anti-clockwise direction and clockwise direction, this might sometime vary for some like potentiometer also. So here, see, in 5K, if I rotate it fully anti-clockwise and if I keep the value, I mean multimeter in left and center pin, it goes 0. See, it is 0. See, now left and center pin I have used. But the same, if I am taking a 1K potentiometer, see, I am rotating the knob to the fully anti-clockwise direction. Now if I take the value, make it to 2K because it is very high. I have taken a 1K potentiometer and I have set the pin to 5K. Okay, so now I have set it to 2K. Now if we check the value, okay, it is 0. And now I will rotate it fully to clockwise direction and I will check the value between the rightmost corner. See, it is showing 1.79. Can you see this? Slowly it will decrease, okay? See, now what happened? Now I have fully closed to your clockwise direction, right corner, and I am using this right 2 pin. It is showing value, which is not the case with this 5K, because in 5K, which if I fully close it and use the right 2 pins, it will show 0. From there we have to slowly rotate anti-clockwise so that your value will slowly increase. But in this case, it is showing some value, so it is maximum value. From here, if you rotate, it will decrease. Okay, so in some potentiometer this will vary, so you have to check this properly before you start using your potentiometer. Okay, so now I will show you how to glow an LED with this potentiometer. So as usual, we have our positive of the battery and the ground. Okay, so I connected it to the pin. So I'll show you the circuit. Before that, I'll show you this circuit. Circuit in the internet. System, and here I'll show you the hardware circuit. Okay. So positive of your supply, I'm connecting it to 5K. Okay. So in 5K, what I'm doing, I'm fully closing my knob to the anti-clockwise direction, so that slowly, if I gradually rotate it clockwise, my value of resistance will increase. Okay. So I'm connecting it to the positive of the supply. So the other end of the resistor, that is the center point, I'm connecting it to one end. So which you can see, this is the positive, this is the output pin. Okay. So now connect an LED positive, that is positive to your output of the resistor and negative to your. So now the LED is glowing brightly, as you can see, because it is fully in closed, which means the resistance is 0. Okay, so we can check the resistance. The resistance is 0 here. Set it to 5K. See, you can see the resistance is 0. Okay, actually it is showing a very minimum value. So slowly, since the resistance is very less, there will be current flow from the supply to your LED, so LED is glowing. Now what should happen? The moment I rotate the resistor in clockwise direction, slowly the resistance value will increase. When the resistance value increases slowly, automatically the current flowing to the LED will decrease. Okay, so that the LED should be switched off. Okay, so we will check it. So I am rotating the knob clockwise direction. You can see the LED is dimming slowly. Okay, but it is not switched off. Why? Because even though we have set the knob to the fully clockwise direction closed, even though we have closed it, some current is flowing, which is enough to glow this LED. Okay, we will check what is the current now. So change it to milliamps. Okay, so how do you connect the current multimeter? So remove this one pin. Always current measurement should be in series. Okay, so connect it here. and other end to this LED, so that the LED is glowing, so that the current flows through the multimeter now. Okay, now what is the value of the current? See, a little current is flowing, 0.68, right? This current is enough to glow an LED, so the LED is glowing. Okay, but the same circuit, you know what I'm doing? I will use this third pin also. Can you see this? In this potentiometer we did not use this third pin. So now what I'm doing, I'm using this third pin. I'm just connecting this third pin to the ground. Okay, I have connected this third pin to the ground, and you can see the LED is switched off. Okay, why? Because I'll tell you why this LED is switched off. Okay, because the current through this center pin is 0. That is why, or it is very less, so that this LED is switched off. Okay, so I'll explain you in detail in this circuit why this current through this is switched off. Okay, so I'll show you in practical. So we have to connect it properly. Yes, so now I connected the third pin, but the LED is not glowing because I connected the third pin to the ground, but still the LED is not glowing. Okay, I'll tell you the reason when I draw the circuit. Okay, so the moment I disconnect this third pin from the ground, the LED will glow. Okay. Yes, guys, now we will see the circuit. So this is the 5 volt. Okay, actually it was 9 volt in our practical case, so we will make it as 9 volt. Okay, so this 9 volt we have connected to the one end of the potentiometer, right? So the other end, I'll tell you what will happen if we use 3 pin and 2 pins. Okay, so now in this case the third pin of the potentiometer we are leaving it as it is, the center pin. Okay, so we are taking output, at that pin we are connecting an LED. Okay, actually we were using a 5 mm LED. The other end of the LED we have connected to the ground. Okay, so another circuit, from the 9 volt we have connected it to one end of the potentiometer. Other end of the potentiometer we have connected to the ground. That is the third pin. Center pin we have taken it and connected to an LED. And the LED cathode we have connected it to the ground. Okay, so these are the two circuits which we saw in the practical case. Okay, so now what will happen, as we have seen in the practical case, in this circuit, even though we have fully rotated our potentiometer to its maximum value, the LED was glowing. But in this circuit, as I showed you, the moment our resistance, we keep increase our resistance, the moment the resistance increases to a maximum value, that the current reduces beyond this limit minimum current required to glow this LED, this LED got switched off. Okay, so I showed you in the practical, if we connect the third pin to the ground, this LED was switched off. But if we did not connect this third pin of the potentiometer to the ground, the LED was still switching on, because the reason is, even though we have increased the potentiometer to the full maximum value, that is 5K. Okay, we have used 5K potentiometer, still there was current flowing. That is because there is only one path for the current to flow to the ground. See, from the 9 volt there is only one path. See, this is the only path for the current to flow. But in this case there are two paths actually. See, one path is through resistor, other part is through this value. So since there are two paths, the current flowing through this LED was very less. So that is why in this circuit the LED got switched off, whereas in this circuit the LED did not switched off, even though we rotated our potentiometer to the maximum value, which is 5K. Okay, because when there is only one path, all the current will be flowing through this path only. But when there is two paths, the current will get divided. So the current flowing through this LED was less. So that is why the LED did not glow, which means by default, since these two are in parallel, the current got divided. Okay, so that is the reason this LED was blown off, whereas this LED in this circuit was still glowing even when the potentiometer was fully closed. Okay.